Aloha guys, this is Dr. Tom coming back at you. Today we're going to talk about the spinal cord. The central nervous system is the brain and the spinal cord. So let's hit it, man. The spinal cord is a continuation of the brainstem of the medulla, actually. Tube-like structure located in the spinal cavity. Extends from the foramen magnum, the big hole in the occipital bone, down to about L1. There it branches off into a bunch of little nerves called the cauda equina. Now, this is absolutely incorrect. How do I know? Because I have seen human spinal cords a number of times in my dissection labs. They're closer to the size of a pencil in diameter. They are nowhere near as big as your thumb. Every time I teach this course, I make it very plain that that is incorrect. It's much smaller than that. It's amazing because there's a lot of stuff packed in there. Okay, for different reasons, for anesthetic reasons or for diagnostic reasons, anesthesia. They sometimes have to do a lumbar puncture where they go in there and puncture in to get into the cerebrospinal fluid, into the subarachnoid space. Now, they do it at L3 and 4 to stay away from the spinal cord. Where does the spinal cord end? L1, approximately. Gray on the outside, inside, white on the outside. Remember what's white matter? Myelinated fibers. The gray matter is the dorsal horn, the ventral horn, central canal. We'll see a drawing in a moment. White matter is location of the tracks and decussation. Okay, so here's a section that's about T4. And it looks like a butterfly, guys, when you do a cross section of it. Here's the gray matter, although it's browned here. And here's the white matter. Now, up and down the spinal cord, these different tracks run in these columns. And it's really complicated, really. They're only hitting just a tiny little bit of it here. Remember, ascending tracks are sensory. Descending tracks are motor. Anything going up the cord towards the brain is sensory information. Anything coming down is some sort of a motor type information. The spinal thalamic and corticospinal tracts and the dorsal columns. Here's the front, by the way. It has that split. Here's a little central canal. Are nerves that have similar functions that are bundled together into what are called tracts or columns. Now, this is really, really complex. We're only seeing the supreme highlights of it. Spinal cord tracts, ascending, which of course anything ascending is going to be sensory. Spinal thalamic is pain pathway. Dorsal column, spinal cerebellar, they're all sensory, but they don't go into any more detail. Hey, that's okay. Guys, this is, believe me, more detail than you want to get into. Descending tracts are motor. The pyramidal tracts or pyramidal tracts are the major motor tracts. And then there are extrapyramidal. I think it's more commonly called pyramidal. I've heard it both ways. Okay, spinal cord injuries. Unfortunately, this is actually a common one, where a person dives into a shallow area and breaks their neck or damages the spinal cord. Quadra means 4, of course. This person is paralyzed in all the areas that are gray. Paraplegia means 2. In this instance, this person is paralyzed from the waist down. Depending on how bad the injury is, they might regain some function, they may not. It's really sad. The spinal cord is very slow to heal, if at all, guess. Okay, now, there are 31 pairs of spinal nerves that come out off the spinal cord and go out between the vertebrae. Here we're starting to see it. So here's a cross section of the spinal cord right here, mid-thoracic area. There's a dorsal root in the back and there's a ventral root in the front that comes off of here. They join together, form a nerve and go, one of the spinal nerves, it doesn't say which one, doesn't matter, and it goes out from the opening between the vertebrae and then does its thing. Many of these have motor and sensory function. So like this, in this case, the sensory function is going to the skin. It detects pain, let's say. And then the motor portion of this spinal nerve goes to some of the skeletal muscles. In these spinal nerves, the cell bodies are outside of the spinal cord, right here. And they're called ganglion. So this is the dorsal root ganglion. Now, most all these nerves have this same pattern, guys, are very similar. Now, I know you're going to have to go back over it. I know it's complicated. What the spinal cord does, well, it has sensory pathways taking sensory information up to the brain. It has motor pathways bringing it down to the muscles, and then it has reflex centers. Reflexes are real important. There are a lot of different reflexes in the body. This is one of the best known ones. It's called a deep tendon reflex. So you've had this probably done, guys, where they take the little rubber reflex hammer and tap your knee and it jerks. What a reflex is a protective mechanism. The sensory information goes into the spinal cord, then it's routed right back out again to the muscles and makes it jump. It does not go all the way to the brain. Why? It saves time. It saves time. This reflex is to keep you from jerking the ligaments and tendons loose from the bone, primarily tendons. And that's what it's designed for. Now, another famous example is when you touch a hot surface, like here, the withdrawal reflex, and you jerk your hand away before you even realized it was hot. That's a reflex protecting it, guys. The sensory information goes into the spinal cord, it crosses over to the motor nerve and right back down, and boom, you jerk it back. Will you still get burned? Yeah, but a whole lot less than if it took another second or two to go up to the brain and back down. A second is a long time, guys. It's 1,000, 2,000, that's a second. You can have the pee-pee burned out of you in that period of time. Now, there are also other reflexes, like the pupillary reflex. When you shine a bright light, the pupil should constrict. I don't want to go into this one. Babinski, just your toes flex in a certain way. The knee jerk we just talked about. Look over these guys, just in the event that they're very likely to be on a test. Nerve versus a neuron. What's a neuron? Nerve cell. What's a nerve? A bundle of axons. Period. How do they define it? Bundle of neurons. Yeah, but it's specifically bundles of axons. The cell body and the dendrites aren't there, just the axons are. And of course, a neuron is a single nerve cell. Also, too, a nerve has fascia wrapping around it and blood, and it has vascularized, has blood flow to it. Important to know, but relatively simple. Okay, now, the CNS is the brain and the spinal cord. Everything else is the PNS, the peripheral nervous system. It has two broad categories of nerves. It has 12 pairs of cranial nerves, which are very specialized, and 31 pairs of spinal nerves. Functional classification, where nerves go, what they do, structures, where they come from. Okay. The cranial nerves, guys, are real important, and they're quite complex. There are 12 pairs of them. They all originate in the brain or brainstem. It's where their nuclei are found. And they do highly specialized stuff like vision, hearing, taste, all that kind of thing. Some of them are sensory, some of them are motor, and many of them are mixed and have both. For example, cranial nerve 2, the optic nerve, is just sensory. That's all. It takes our vision signals and sends them back to the occipital lobe where it's processed. Okay, here they are. They're always abbreviated with Roman numerals. Number 1 is olfaction, smell. Number 2 is the optic nerve, vision. Number 3 is the trigeminal nerve, has 3 branches, controls muscles of facial expression, and some other things. Where's number 6 at? There are a number, number 3 is oculomotor. There are 3 separate cranial nerves, guys, that just deal with eye movements. The trochlear, the abducens, which is 4, 6, and 3. Number 7, the facial nerve, muscles of facial expression, sensations in the face, and some other functions. Very complicated. Cranial nerve 8, vestibulocochlear, is the nerve that we hear through and also deals with our balance. Number 9 is the glossopharyngeal, innervates the tongue, makes it move. Number 10 is the vagus nerve, largest one. It runs down the front of the spinal column and gives branches to all the major organs. Vagus means wanderer in Latin. This is 12. Where's 11? 11 is the accessory nerve, spinal accessory. It gives innervation to the trapezius muscle and the sternocleidomastoids. And number 12, hypoglossal, controls the tongue. Some of the taste, I think, too. So that's the 12 pair, guys. It's quite complicated. They're most often abbreviated by the Roman numeral, but they all have this name, too. Here they are here. Let's go back over. Cranial nerve 1, olfaction, smell. Cranial nerve 2, optic nerve, sight. Cranial nerve 3, oculomotor, most movements of the eyeball, the eyelid, and pupil size. Cranial nerve 4, the trochlear, movement of the eyeball. Cranial nerve 5, trigeminal, has 3 branches, that's why it's tri. Chewing, sensations in the face, scalp, cornea, and teeth. If you have a toothache, this is the sucker that's making you miserable. Sensory arm or the corneal reflex, if you touch like a little piece of cotton to the cornea, your eye will blink and all. Trigeminal neuralgia, tic douloureux, is a disease affected with that. It also has the name tic douloureux. Cranial nerve 6, abducens, eyeball movement again. 3, that's different from the optic nerve, which sees. These just move the eyeball around, but it's that complicated. Cranial nerve 7 is the facial nerve. Facial expression, salivation, meaning secretion of saliva. Taste, tearing of the eyes, blinking. Motor arm of the corneal reflex. Bell's palsy, which is another pretty common disease. Cranial nerve 8, the one for hearing, vestibulocochlear. It used to be called the auditory nerve, but of course, yeah. But the thing is, though, guys, to be fair, the ear also controls balance and all, too. So that's the vestibulocochlear portion, hearing and balance. Vestibular branch deals with balance, cochlear branch with hearing. Cranial nerve 9, glossopharyngeal, swallowing, secretion of saliva, taste. Gag and blood pressure reflexes. Cranial nerve 10, vagus, the wanderer. Nerve innervates many thoracic and abdominal organs, voice box, sensory arm of the baroreceptor reflex. We haven't talked about it. If you take and press both carotid arteries and include them, you can trigger a reflex and make the heart stop. Not good. Cranial nerve 11, accessory, head movement, shrugging shoulders, swallowing. Cranial nerve 12, finally, the hypoglossal, speech and swallowing. How many cranial nerves are there? 12 pair. Their nuclei all originate in the brain or the brainstem. Spinal nerves, there are 31 pairs of them. Fortunately, they don't have names. They're just named after where they exit out of the spine at. There are 8 cervical nerves, 12 thoracic, 5 lumbar, 5 sacral, and 1 coccygeal. Now, this is the first time we've seen this. I mentioned it a moment ago. The spinal cord ends at L1. There, it branches off in just a bunch of nerves called the cauda equina, which is Latin for horse's tail. Somebody with a lot of imagination thought it looked like a horse's tail. Okay? Now, nerves come together to form plexus, C's. The cervical plexus is C1, the nerve roots from C1 and C4 to C4. The brachial plexus, which goes in the arms, brachial means arms, C5 to C8, and also T1. Now, there's 7 cervical vertebrae, but there are 8 cervical nerves because they come out at the top and the bottom and all of them in between. The lumbosacral plexus is T12, L1 through 5, and 4 of the 5 sacral segments. These make the nerves that go to your legs. These are the roots that make up the nerves that go to your arms. I'm trying to finish, but I don't think I'm going to be able to. Important spinal nerves from the cervical plexus. Phrenic nerve goes to the diaphragm, controls our breathing. If it gets damaged, you're in big trouble. You're going to have some assistance to breathe from that point onward. Brachial plexus forms the axillary nerve, goes to the armpit. Radial, ulnar, and median nerves are all important nerves of the arm. There are 5 major nerves that go into the arm. Lumbosacral, femoral, obturator, sciatic, tibial, common, perineal, or peroneal. These are major nerves in the leg. If you have a damage to the... Let's see if we can finish this, guys. Okay, a dermatome is a patch of skin innervated by a spinal nerve. For example, C5 innervates this. If somebody pokes a pin into you and that, it stimulates C5. Somatic, efferent, autonomic. Yeah, we're going to finish up. Somatic means body. Autonomic, we'll talk about in the next one, guys. It's all the automatic stuff that you don't have to think about. Go back over this. We hit it fast. but you can do it. This is Dr. Tom signing off. We'll see you next time.